Okay, in this video, we are going to have a look at a GPS receiver, that's Global Positioning System, and this is the receiver here. It's a Neo 6M. Now this is an older design, but there's still lots of them out there. Now this is the antenna, which you can see here, and that points up towards the sky without any obstructions. And on the back is actually the GPS electronics. And it has 5 pins that we hook up to our breadboard. The first pin is 1 pulse per second output. Then we have our UART output, or TX and RX. Then we have the common ground and VCC, which we're going to be running 3.3 volts, and that's going to come off our microcontroller board. So we could plug this into our breadboard, and then we could have a look at the TX output. Now the TX output is going to send out some ASCII strings, and they're NEMA 0183 protocol strings. And in these strings is going to be the data that we want to extract. So there's 2 sentences that we're going to use. It's the GP, GGA, and GP RMC. And with those 2 sentences, we could extract the data for our GPS projects. So we'll have a look at those 2 sentences and what kind of data there is in the data fields. Okay, next, we're going to have a look at the 2 sentences that we're going to get from the GPS module. This is the GP GGA sentence and the GP RMC sentence. Now these are ASCII string sentences, and they're under the NEMA protocol, the NEMA 0183 protocol. So from the GP GGA sentence, we could get time, that's universal time. We could get latitude with the direction north and south, longitude with the direction east and west. Fixed quality, 0 means there's no satellites, it doesn't see any satellites. 1 means it has enough satellites to give us a lat long output. And 2 is differential GPS. The number of satellites that it's being used, and the altitude above sea level in meters. So that's the GP GGA. Now if you go online and you search for GP GGA sentence, you could actually get a map that will tell you all the values of each field. The next sentence is the GP RMC, and from this sentence we get the speed over ground in knots. And if we're moving, we'll get a bearing, that's the degrees from north, and we'll get a date, the day, month, and year. So using these 2 sentences, the GP RMC and the GP GGA, we could get enough information for a GPS project. Okay, I plugged my GPS receiver into my breadboard, and I have it connected up to my Scamp3 board. So here's the schematic. So the Scamp3 board is feeding 3.3 volts to power the GPS module, and the TX output of the GPS module, that's the UART output, is fed into the RX1 input of the Scamp3 board, so that's the UART input. And the TX output of the GPS is 9600 baud, so those are the NEMA sentences, the output NEMA sentences, the GP, GGA, and GP RMC. So they're going to be fed into the Scamp3 board, and then we're going to write some code where we're going to extract that data and get that data, the 2 strings, into the Scamp3 board. Okay, I have TerraTerm up and running on my computer, and it's connected to my Scamp3 board, which is connected to my GPS receiver. And I have a little program, it's called NEMA, stands for National Marine Electronic Association. It's a very small program, it's only 110 bytes long. I'll run it. And there's the strings that are coming out of the GPS receiver every 1 second. So I'll hit any key in the keyboard and I'll stop it. Now you can see it's not picking up any satellites, so we're not getting any data. If you look at the GP GGA sentence, that's this one right here. If you look at this number here, this number means the quality of fix. That means it doesn't see any satellites. This is the number of satellites, and it's 0. And if you look at the GP RMC sentence, this V means void. So right now it's not picking up any satellites. It's trying to hunt for satellites to get a fix. It hasn't got a fix yet. It'll take a bit of time. Plus I'm in my house, so we're probably not going to get very many satellites. So this is the GP GGA sentence. It starts with the $, ends with an asterisk, and after the asterisk is a checksum. GP stands for GPS system, the United States GPS system. GGA is the name of the sentence. And this is all the data, and it's all separated by commas. So if you look at the GP GGA cheat sheet, the chart, and it'll give you all those values that are in those fields. So there's our GP GGA sentence, and our GP RMC sentence is right here. Starts with a $, ends with an asterisk, and after the asterisk is our checksum. And we have a V here for void, so we're not picking up any satellites. So I'll give it some more time. We'll pick up some more satellites, and I might have to go over to our local school
where we have a playground and a parking lot. I could get some probably good readings there. So I'll wait a while until we get some proper data, and I'll run this program again. Okay, I gave the GPS some time to get a fix on some satellites. So I'll run the program again, Nema. And there's our strings, and you can see we have lots of data there. So I'll hit any key to stop, and we'll have a look at the GPGGA sentence, which is right here. And we can see there's our time. That's our first field. The next field is our latitude. Direction is north. And there's our longitude. Direction is west. 1 is our fix. So we have enough satellites to get a latitude longitude fix. And there's number of satellites, 6 satellites. And here's our altitude above sea level, 41.8 meters. So if we look down at our GPRMC, which is down here, same thing. There's our time and our latitude, longitude. And right here, A means active. It's not V anymore. Before it was V for void. Active means it sees enough satellites to give us some information. So we could now parse out the data because we know the fields. We could look up on our chart, or we could copy and paste these Nema strings into a website that'll actually parse out the data. So if I copy the GPGGA sentence, so I'll do that. I'll copy this whole sentence, and I'll go to a website, and we'll decode it. We'll parse out the data. Okay, here's a website that will decode GPRMC and GPGGA sentences. So it'll extract the data out of the data fields, and you see I copied it and pasted it into this text box. So I hit decode. Now it's going to decode the string. So it gives me a map. And if you look at the very right, you see decoding results. There's our time, universal time. Fixed quality is 1. There's our lat-long position, satellite 6, and altitude is 41.9 meters. And I could zoom in into the map, and it should take me to the school. We could zoom right down. So there's the school where I'm at, picking this up. So now we could decode these 2 sentences, either GPRMC or GPGGA, or we could write our own code and decode it. But this is just to get us going. Okay, next, I'm going to demonstrate some parsing code written in Forth. And if there's any interest, I can make another video. So I'll type Nema, so we can look at the strings that are coming into the microcontroller. So there's our strings. So I'll hit any key to stop, and I'll clear the screen, and I'll type get GPGGA. So it's going to grab the GPGGA string and put it into a buffer, and there it is in a buffer. So while it's in a buffer, now we could go parse the string in the buffer, and there it parsed it. So you could see GPGGA. So there's our first field, it's our time. Second field is our latitude. Third field is north. Fourth field is longitude, and it goes all the way down. There's our altitude above sea level. So that's a way we could parse it, or we could use the word field. So we go 1 field, and there's our time. We go 2 field. There's our latitude. 3 field. So with the word field, we could extract each field out of the Nema sentence. So field is a very powerful word. We could use that as a building block to build larger and more powerful words. Okay, using field as a building block, I wrote some code called getGPS, and that's going to extract the fields from both of the sentences. So I'll run that, called get.gps. So there's all our data. So we got our time, our date, latitude, longitude. Our fix is 1. Satellites are 8. Altitude above sea level, 39.7 meters. Status is active. Speed, it's showing 0.076 knots, but we're not actually moving. And because we're not moving, the bearing here is null. It's empty. So anytime we want an update, we just type get GPS, and it'll give us an update of all the fields of the 2 sentences. Okay, here's the code running in the Scamp3 board to display the Nema sentences coming from the GPS module. So the main word is Nema, but first of all, I have a word called wait for $. So as the strings are coming in, it's going to wait for a $, so we have a clean beginning. So when it sees a $, it's going to continue on with the word Nema. So first thing we do, we set the baud rate to 9600 baud to match the baud rate of the GPS. And this cleans out the buffer, the UART buffer. And then it's going to wait for the $. And as soon as it sees a $, it's going to start taking in data. And it's going to display it on the screen until I hit any key on the keyboard. So this is in a begin until loop. So it's constantly reading the Nema strings and displaying them until I hit any key, and it will stop. So that's the word Nema. So it's very simple. This whole program is only 110 bytes, and you can run it on a Scamp3 board, and then you could pull in the Nema strings from the GPS module.
Okay, so that was my little tutorial on how to get started with GPS. So now you can incorporate a GPS in your project. You don't have to use this specific one because all GPSs have the standard output, the NMEA 0183 protocol. As long as you get the baud rate correct and it's UART compatible, you could feed it into the Scamp3 board and run the same code. Then you could check out the strings, and you could use the chart to decode the strings to pull out the different fields, or go online to that website and it will decode the strings online.